Okay, welcome to our lesson 2. Lesson 2 for this chapter. Chapter 1 talks about factorization of polynomials, and lesson 2 talks about factoring polynomials, focusing on difference of two squares. But before we go, we go in with this different factoring difference of two squares, let us first settle on the concept of squares. So when do we know if a certain expression, um, either is it a square or not a square expression? So let us say here number 4 for x square. Since we can split this into 2x times 2x, since we can factor it into two the same factors, that makes it a square. 3x square, we cannot split it into, we can only split this into 3x times x, and they are not the same factors. This is not a square. 9x raised to 4, we can split this into 3x times 3x. That means this 9x4 is a square number, is a square expression. 100xy x square y raised to 4, we can split 100 into 10 times 10, x square into x times x, and y raised to 4 to y raised to square and y raised to square. So eventually 100x square y raised to 4, we can split it into the same factors, 10xy square each. This is a square. 25x cubed, though 25, we can split it into 20 of 5 times 5, but x cubed we can split only to 3 square and x. They are not the same, so this is not a square. So this is important because when we apply difference of two squares later on, we have to look first if they are really squares, from the word difference of two squares, subtraction of two squares. Okay, let's continue with this. So we know in our discussion that difference of two squares are in this format. Okay, if you want to learn how the visual proof, okay, if you want to learn the visual proof, how come x square minus y square becomes x plus y times x minus y, there's a link in the description. You can click that and watch the video, the visual proof for this difference of two squares. So to give a formal, a little bit of proof for this one, we can we can distribute the right side. So this becomes x square, this becomes minus xy, this becomes plus xy, and this becomes minus y square. Notice that the two middle terms become 0, and we are left with x square minus y square, which is actually this one. So to factor x square minus square, that becomes x plus y, x minus y. So let's proceed to our example number 1. Our example number 1 is x square minus 4. So x square is a square, 4 is a square, then the operation is difference or subtraction. So we can just factor this into, this one is x times x, then that is plus and minus. 4, we can split that into 2 and 2. Number 2, we have 4x square minus 9. So 4x square is a square, 9 is a square. The operation is minus or subtraction, so we can split this into 4x square is 2x and 2x, then plus and minus. 9 is 3 and 3. Number 3, we have 4a square b square minus 25. 4a square b square is a square, 25 is a square. The operation is minus, so we can split this into, so 4 becomes 2 and 2, a square is a and a, b square is b and b, then plus and minus. 25 is 5 times 5. 9p square is a square, 49q square is a square. So can continue with our method a while ago. So 9p square is 3p, 3p, then plus minus 7q, because 49 is 7 times 7, q square is q times q, so 7q. So this is the factored form. Let's continue. Here, as you can see, it looks like that that the expression is not a difference of 2 square. But always remember, before you go to different methods, different techniques of factoring, there will be a lot of methods on factoring algebraic expressions. And the very first method that you should observe is the common monomial factor. We will the lesson in lesson 1, okay? Take out first the common monomial factor. Okay, the common monomial factor is the common between 2x squared and 8y squared is 2. So you're going to find what's remaining inside. So that's going to be x squared minus 4y squared. Notice that what's inside is now a difference of 2 square. X squared is a square, 4y squared is a square, and the operation is minus. So let's continue factoring what is inside. So x and x, plus and minus, then 2y and 2y. The same so with number 6. 12 and 3, the common monomial factor is 3. So we are left with the first term, this one divided by this one, that's going to be 4x raised to 4, minus this one divided by this one, that's going to be y squared. Notice that what's inside, okay, the 4x raised to 4 minus y squared is now a difference of 2 squares. So we can continue with 4x4, we can split this into 2x squared, then the y squared, we can into plus y and minus y. So this is our complete factor. Okay, so take note again, starting now, do not go to the next factorization first without going through checking if there is a common monomial factors. Check first, step 1 should be check first the common monomial factor. If there is, then take out that, then factor what's remaining inside according to different kinds of factorization technique. Okay, if there is no common monomial factor, then you can proceed with any other factoring techniques. Number 7, we have, this one, a plus b square is a square minus 1. So we'll just simply split this into a plus b square. Remember that a plus b square is, in our grade 7, we have a plus b times a plus b. So that's going to be a plus b here, then a plus b here. Then plus and minus, 1 is 1 and 1. That is our factor. So a plus b plus 1 times a plus b minus 1. So here we have number 8. It's the same. This should be square. So we have here split 3a minus 2 square into 3a minus 2 times 3a minus 2. So that is 3a minus 2, 3a minus 2. Then the operation should be plus and minus. The 25 will give us 5 and 5. So that is 5 and 5. Now the thing is, we can still simplify this portion. Okay? So that is 3a plus 3 and 3a minus 7. Notice here that we can furtherly factor 3 and 3. Okay? So our final answer goes 3 a plus 1, so that is for this one, the 3a plus 3. And since 3a minus 7 has no more common factors between their two terms, the 3a and 7 and minus 7, we will copy this one. This is our final factor. Number 9, we have this one. So it's the same idea with 7 and 8. We simply so we have x plus y square, so that's x plus y here, x plus y here. Then let's try to have plus and minus. Then let's try to have the x minus y, that's going to be x minus y. There no need to worry here because the sign is plus, so no need to enclose x minus y with parentheses. But our concern is here minus, so we need to enclose our next factor with parentheses, like that. So when you encounter this one, double parentheses, the outside parenthesis will become now your bracket. Okay, then that's the time we simplify. So as you can see here, notice that we can simplify plus y and minus y, and that becomes 0, and x and another x, that becomes 2x. So this portion will be simplified into 2x times this one, x plus y. Okay, then this is minus x and plus y. Okay, so we will have, look at x and negative x, that will become 0. You are left with 2x, and this one is 2y. Okay, so the factors are 2x and 2y. We can simply simplify it into 4x. 2 times 2 is 4, then 4xy. Okay, so the factors are 4x and y. Okay. For number 10, we have the same idea. So let us, since this will be minus later on here, like that, we'll just have to prepare that this one will become a bracket. So in this one is we are going to split x plus 5 square into x plus 5 and x plus 5. Then the y plus 2 square is here, y plus 2, and another minus, since minus, that should be enclosed with parentheses, y plus 2. Okay, then this is the time that we try to simplify this one. So x and y, so that's x plus y, plus 5 and 2 becomes 7. Then here is, so just have to copy, then distribute this one, that becomes minus y, distribute this one, becomes minus 2. So our final factor are x plus y plus 7 times x minus y, 5 and negative 2 will become positive 3. So that is how we apply the difference of two squares in factoring this one, factoring expressions in terms of this.